I'd like to start by thanking you all for coming. Allow me to introduce myself. My name is Vladislav Pakhomov, and today I am going to talk about the use of ash and slag waste in the production of building materials. I want to start with a problem. The current scale of environmental changes pose a real threat to the life and health of the population. An urgent problem of the rural community is the increasing risk to human life and to health as a result of the impact of economic activity on the environment. The task of recycling industrial waste, including ash and slag, results in a serious problem. Their use in construction production allows you to save on the cost of basic expensive materials without compromising the quality of the product while solving the problem of recycling. Let's consider this in more details. The level of ash and slag waste utilization in Russia is about 4-5%. In a number of developed countries, about 15%, and France and in Germany 70%, and in Finland about 90%. Of their correct output in these countries, dry ash is mainly used, and government policies have been implemented or to encourage their use. So in Poland, the price of land for ash dumps has been sharply increased. So thermal power plants (CHP) pay extra to consumers in order to reduce their own storage costs. In China, ash is delivered to consumers for free, and in Bulgaria, where ash itself is free, there are 5 regional ash distribution centers in the United Kingdom. The solution of the environmental problem of utilization of ash and slag waste of the CHP is shown by the example for experiments conducted on the use of ash of the CHP. Now we'll move on to mathematical planning of an experiment for the production of structural ash concrete. Purpose of development to obtain a building material using full ash, namely structural heat insulating ash concrete with a volumetric mass of 600-800 kg divided by M3 and with a compressive strength class B2. The composition is set by 6 components: cement, water, ash, lime, aluminum powder, and soda. Mass fractions of the components related by the ratio. ME, the mass of each component. The output parameters depend on the composition. Sigma, compressive strength kg divided by cm2. Uh, Gamma, volume mass of gas reinforced concrete kg divided by m3 and others. The strength and the usual mass of added concrete, in which sand is used instead of ash, is determined by the ratio of the mass of water, sand, additive deferred 44 to the mass of cement, respectively. Therefore, we will take the following rules as factors. The ratio of the masses of water, ash, lime, additive, deferred 44 sold respectively to the mass of cement included in the composition. The task is formulated as follows. It is required to set up an experiment in such a way that at minimal cost to conduct it, to obtain information from its results sufficient to build adequate mathematical models, and find the roles of the factors AE would tell the response functions extreme values. To build response surfaces, the method of steep ascent is used. In this method, each of the factors varies at two levels. Where those of factors close to those in the production of conventional concrete were used as levels, where achievement for ash levels was carried out by conversion to sand according to the content of aluminum dioxide in them. The lower level is encoded as -1, the upper +1. The plan of the experiment, its results calculated from the regression equations obtained on the basis of the experiment. Responses sigma and gamma were formulas for the transition to code variables given in Table 1. The plan of the experiment its results. Table 1 factors and their levels in the first series of experiments. Next. To find the composition mathematical planning of the step-by-step optimum search experiment was used. At the first stage, five factors varied. The ratio of the mass of water to the mass of cement in the range from 0.45 knot to 0.85 knot. The ratio of hash mass to cement mass in the range from 1.4 to 2. The ratio of lime mass to cement mass in the range from .01 to .03. The ratio of the mass of the third 24th to the mass of cement in the range from .9 knot to 1.1. The ratio of the mass of soda to the mass of cement in the range from .0026 to .006. The experimental plan, its results, and the responses sigma and gamma calculated from the regression equations obtained on the basis of the experiment are shown in Table 2. Experiment of the first stage by the method of steep ascent. The plan of the experiment of the second stage was developed and implemented. Regression equations have a form. The values calculated according to these equations are given in Table 3. In each experiment, the use of mathematical methods for step-by-step improvement of the plan allowed experimentally to find the composition of gas-reinforced concrete used in construction that meets the requirements of GOST 2548589 in terms of strength and lightness. Table 3, Plan PPA2, and the results of the experiment. Let's summarize briefly what we've looked at. Firstly, in modern conditions, the crisis solves the severity of the problem of disposing of ash and slag materials from combustion of coal in thermal power plants. The accumulation in increasing volumes leading to a rapid increase of environmental, social, and economic costs because of the extremely low level of utilization. Secondly, the use of ash waste saves the cost of basic expensive materials without compromising the quality of the product, simultaneously solving the disposal problems with slady materials. Thirdly, the use of waste increases profitability. Fourthly, slab-selenium waste processing allows to stabilize the environmental situation in the country. Fifthly, a complex use of natural rare materials and waste leads to an increase in the level of the national economy of materials and goods. Rational distribution of productive forces to reduce different cost items and therefore enhances the efficiency of capital and investments in the national economy. Sixthly, The use of mathematical methods for phased improvement plan allowed experimentally to find the composition of salamander used in construction for strength and lightness meet the requirements. Blocks are used for the construction of hidden chambers and line the foundations of the pumping stations at the wells. And for low-rise buildings for production purposes, boilers, pumping and pumping stations, and water lifting stations. Thanks for your attention.